Welcome viewers, in this video we will see the reduction of switching equation by Boolean Algebra. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, link is given in the description box. Now we'll go to the topic. By the Boolean Algebra we are going to reduce the switching equation. In this problem based on the theorems, we are going to prove the theorem. You see the first problem. Prove that a plus a bar b equal to a plus b. We need to prove that a plus a bar is complement of a is equal to a plus b. Now we'll take this a plus a bar b equal to a plus ab plus a bar b, right? So that is based on the absorption property, a plus a bar b equal to a, right? So this a is written as a plus ab. Based on the absorption theorem, the a is replaced as a plus ab. Now a plus ab plus a bar b. Now a plus, you take b outside. In these two terms, b is available commonly, take b outside, so that a plus a bar. What is the a plus a bar? A plus a bar equal to 1. If a equal to 1 means a bar will be 0. So that 1 plus 0, 1. If a equal to 0 means a bar will be 1. So 0 plus 1, 1. So a plus a bar always give 1, that is based on the complement property. So that a plus b into a plus a bar become 1. So a into b dot 1, that is nothing but a plus b, right? So that a plus a bar b, now it is equal to a plus b. Now we proved the theorem, right? So this theorem can be used for further simplification in other equation, other switching equation. If you have the expression a plus a bar b, that can be written as a plus b. Now we'll go to the second problem, second theorem. A bar plus b equal to ab. A bar plus ab equal to ab. A into a bar, this a into a bar plus b equal to a into b. Previous theorem based on the OR operation, this theorem based on the AND operation. Now we'll take this side, this left hand side. A into a bar b equal to a plus ab into a bar plus b. So this ab is replaced as a plus ab, like previous problem. Previous problem also we replace a equal to a plus ab, right? So here also this a is replaced by a plus ab. Now multiply each and every term inside, multiply both the terms. A into a bar, a into a bar, a into b, ab, then ab into a bar, ab into a bar, ab into b, ab into b, right? So all four terms are written. A into a bar is nothing but 0. We have the complement property a into a bar. So a equal to 1 mean a bar will be 0. A equal to 0 mean a bar will be 1. So 0 into 1 or 1 into 0 always 0. Then ab is written as it is, right? Here also we have a into a bar b, that is also 0, right? A into b into b, b into b can be written as only b, right? No need to write b again. So the b into b will give only b value, right? So that for going for the further simplification, what we have, ab plus abb, abb is written as ab, right? So ab plus ab, right? So ab plus ab is again nothing but ab only. So a plus a equal to a. So one theorem is available based on that ab plus ab equal to ab only. So that we prove that a into a bar plus b equal to a into b. Now proved the second theorem also. So while simplifying any Boolean expression, if we have the term a into a bar b means we can replace as ab, right? So in this video we discussed the two theorem. We proved the two theorems. One is a plus a bar b equal to a plus b. Another one a into a bar plus b equal to ab, right? So some more problems are available in separate videos. The links are given in the description box. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. The full digital system full material is available in the drive, and also full video link also available in the description box. Thank you for listening.